Hello, everybody. Welcome to the webinar itself. Good morning, good afternoon, good evening, depending on where in the world you are today with us. It's good evening for myself, coming to you from Melbourne, Australia. So before we begin, I would like to acknowledge that the land that we are broadcasting from tonight from IT Masters is the land of the Wurundjeri people of the Kulin Nation. We'd like to pay our respects to their elders past and present and acknowledge that their sovereignty over this land and their waters and culture is never ceded. Welcome back to, or welcome if it's your first time, to the third topic of our DevOps short course hosted by IT Masters and Charles Sturt University. My name's Jack. I'm an eligibility and assessment officer with IT Masters and course consultant, sorry. We've also got joining us the wonderful Brenton Birchmore, who is a fantastic subject mentor and short course presenter and mentor with IT Masters and has been for many years, extremely experienced in developing and delivering content for ITM and CSU. And of course, the wonderful Kit as well is on the back end doing tech support and helping out with making sure everything runs smoothly this evening. So thank you very much to Brenton and Kit. Before we get started on the actual content, just a reminder that there are two abilities for you to chat with us. There's the Q&A section and the chat section. The Q&A is where you would put any questions that you have directly for Brenton on the content of the session itself. So if it's about the information that is being provided as part of the short course itself, and you have a question that you would like Brenton to answer on the air, then that would go in the Q&A section. Not all of the questions will be able to be answered, but we'll have several moments throughout the evening or throughout the session that we'll have the opportunity to go to Brenton and have a bit of back and forth about that. So feel free to put any questions in there. And if you have comments or, questions that you would like to ask of other participants, as well as questions on the administrative side of IT Masters and CSU, then feel free to put those in the chat section. So navigate to the chat icon down the bottom of your Zoom, select who can see your messages as everyone in the drop-down menu, if it's not already there, and you'll be able to have a chat with other panelists, with the other participants, as well as Kit and myself. Once again, all of these webinars are recorded, and that recording is posted at learn.itmasters.edu.au. That's where you can find the recordings of previous sessions, as well as all of the other materials, including some pre-recorded lectures, I suppose we might call them, or other course materials in the and the forums as well, which hopefully people have been utilizing to discuss their thoughts and feelings about these sessions at learn.itmasters.edu.au. So that should just about do it for the housekeeping for this evening. Thank you very much for everyone that has come along. It's fantastic to see you here. And I'll hand over now to Brenton. Take it away.
Hello, Jack. Thank you for that lovely introduction and welcome. And hello, Kit, handling all those things at the back end. Thank you very much. And thank you for everyone for coming along, joining in, tuning in. Fantastic turnout again tonight. We are getting a little bit deeper into some of the more developer perspectives of what DevOps is all about. So we're going to swing the pendulum a little bit tonight and start to talk about what we see as feedback and who needs to get that. So feedback is our theme, but we're going to be having a developer perspective. Now, next week, we will swing that around a little bit and talk a little bit more about the operations perspective and bring the other side of the coin in a little bit more.
And just to clarify there, Brenton, particularly for our Australian students, we will have our session going ahead next week. So next Thursday, same time and place, right, rather than skipping a week.
Right. So carry on, same everything, same as usual for us here. and hopefully all of those who can join in next week. Good to know. I'll be here.
Yes. Yes, as will I.
So our syllabus, what we've tackled so far, this is where we are up to today. We're going to talk about how in a DevOps environment, information needs to move and who gets what. And we are specifically calling it feedback, and that perspective will hopefully become a little clearer as we position what we really mean by that. So we are talking about between the teams, but there's a fundamental flow and tide of information that does tend to happen as a result of the DevOps paradigm. And we're going to explain that along the way as we go. Now, a couple of things I want to point out with all the things that we are discussing here and what we have in the portal. The pre-recorded audio, they tend to be audio lectures of somewhere between sort of 8 to 10 minutes each on average. I know they sound short, but I actually get to pack a lot of information there because it's quite condensed and fairly concise. So there's a lot more in there in some cases, in some ways, than what we were able to cover here in the webinars. Now, we will talk about very similar things, but we won't get to talk about everything. So if you want a bit more, if you want to scratch below the surface, start with those pre-recorded audios and get deeper into that, and you will pick up more things than we're able to talk about here. Having said that, tonight, slightly more freedom with when we choose to stop and answer questions. So I want to encourage you all to put the questions in the question box as we go. We may have a chance to pause and tackle those a little more frequently as we go through our discussions tonight. So hopefully that'll be helpful and useful. Now, what we're going to talk about today, we're going to talk about the rise and the increase in prominence of the role of development in DevOps. So we're going to position them as focus the lens on how they are rising within the DevOps environment and how the DevOps paradigm assists what developers are trying to do. So this is a bit of a background discussion to try and build a picture of how devs see this new arrangement. We're then going to talk a bit about telemetry, what it is, what it means, where it comes from, how we use it, and the terminology from DevOps perspective. We'll talk a bit about how we analyze that telemetry. I've got some examples. We might get into some things there that some of you might already be familiar with. So we might not spend as much time on that, but we will talk a little bit about how those metrics from the telemetry can really be turned into valuable insights, which is part of the feedback mechanisms. We'll talk a bit about peer feedback and how the close working relationship that can evolve during specific moments of the DevOps helps development do what it does and helps operations do what it does. So we'll talk about the close interactions between those two groups. And we'll also talk about the way in which the idea of continuous incremental deployment and delivery actually gives us some fantastic options to get customer and user feedback. Ways that we just wouldn't have access to with other delivery systems and mechanisms. So that's what we're going to cover tonight. Let's start, as I mentioned, with a positioning on the developer's role. And what we're saying here is that for anything that has undergoing ongoing modification, like that's what DevOps is all about, the daily push, the short cycle of lead time to get something that's requested and developed and tested and deployed, for those changes and those constant changes to be successful, it's the role of the developer that has the key function in bringing that quality and success to life. And so the recognition of that within DevOps is saying that whilst operations have an essential role, more often from a sustainability and financial success perspective, where we're meeting our SLAs, we're meeting our KPIs, we are ensuring continuous delivery. Ops is making sure that the bad doesn't happen, but the good that we sell comes from the development perspective and the development activities. And part of what DevOps is doing is saying, well, what do we need to do in combination to make the most of the role that development brings to this environment? How do we leverage that? How do we give it its maximum space and opportunity? And in alignment with that, what do we have to expect from the development? What are devs expected, needed, should do in a DevOps environment in order to bring their best to the value stream. So from development, we can break down the areas in which they operate. Look at those as perhaps sequential. You look at the idea, creation of ideas, where developers are meant to come up with clever code that does clever things. And sometimes this is starting from requests, it's feature requests, things that we want, and really that can come from anywhere. But it's the developing function that says, well, here's an opportunity to deliver some more value, and we need to come up with the ideas from a code perspective that will deliver that value. But we've also got to make it work reliably. Developers have the responsibility, the obligation to make sure that they're creating the right automated testing, running the right tests, designing tests, whether they're done by systems or people, and adjusting and reworking code in whatever way that needs to be in order to continually enhance reliability, so that every time we push code and deploy it, we're deploying reliable code. So that's another part of what development needs to take responsibility for. But as we've already talked about last week, they are responsible for integration. They need to make sure that every new thing or every different thing that gets created and needs to be added will play nice with whatever's already there. So existing code, existing production services and systems, development needs to make sure that that works neatly together and solve anywhere where it doesn't. But we're now starting to stretch over the fence, because we're also saying that developers have an important role to play during deployment, because no matter how great we've done it up until now, something will still go wrong at the point of deployment. And when it goes wrong, it is usually to do with the application layer. It's to do with something that we've added. It's to something that we've changed. And no one is better positioned to recognize it, identify it, test for it, figure it out, adjust it, fix it, roll it back if necessary, and handle all of those on-the-fly decisions that will come out of a code deployment. So in DevOps, we recognize that developers cannot simply step back at the point of deployment, hand it over to the operations and say, good luck. No, there has to be an integral involvement. Then there's the evolution. Then there's the, well, okay, we've done a push. Today's Monday, great. We pushed out some code. We've tested it. We've deployed it. It all works great. And that's the new normal. Now we go back to our options, feature lists, requests, and they may come from what just happened. Something might have just happened in that deployment or from operations or from anywhere that says, you know, we can tweak this, we can evolve this, we can take this challenge and make something better out of it, or take this opportunity and do something more. Now, this is a cycle. We can look at it from a cyclic perspective and say, well, we have the ideation, the code reliability, integrating it, deploying it, evolving it, which brings us back to coming up with more new good ideas. There is no part of the continuous delivery model or process that development does not have a key role in. There's no part. There's nowhere where development gets to step back and say, not our job. So there are bits that they won't necessarily do, but there's nothing that they don't really need to know about at some point. So I want to ask all of you, and this is a broad question. So I want to just be clear. I'm asking all of you to tell me in this poll we're about to launch, how are development teams normally regarded in your IT environment? I'm not specifically saying, what do you think of them? Because I know that most people here are going to have pretty fair and balanced views. But I want to ask you, what's your experience like, either now or in the past recently? Do we have that ready to go, Jack? Have we got that poll ready?
Yes, we do. Just launched.
Excellent. Thank you. All right.
Yes, so we'll take a few minutes to allow people to get their feedback in here. It's just a single choice poll currently. And just I'll take this opportunity for just a quick reminder that questions for Brenton are what goes in the Q&A section, so questions about the content itself. We're going to run through some details around things like the exam a little bit later in this session, and logistics and details on the administrative side of the short course can be directed to the chat section rather than Q&A. Thanks, everyone.
Excellent. Thanks for that update reminder, Jack. I'm curious to see, I'm just watching all the numbers tick over here, curious to see how many people go with the slightly more extreme ends of this poll, and who ticks at the top or the bottom. It might sound like it's meant to be a bit tongue-in-cheek, but it's certainly, there are going to be people out there who have all sorts of perspectives and scenarios in place. And I want with this poll for everyone to see what the answers are, what everyone else sees them as. So we can build a bit of a picture as to what this crowd are experiencing when it comes to the role and the perspective. Because when we see a perspective, we then start to say, well, what's expected of developers? And when we look at what's expected of developers, then we look at, well, what do we need to give them in order for them to meet that expectation? How do we need to create a culture and an environment that supports development doing what's expected of development? And if we're not expecting certain things of development, are we letting our entire organization down? You know, if they're kept out of things, is that really helping us? And that's the question that DevOps wants us to consider all the time. The more segregation we have, you have to ask, is that helping? And if it's not, if there's a merging, blending, or alignment that can help, how does it help and how do we do it? And that's what DevOps is asking us to do. How are we going with our numbers of participation?
Well, it's just been about, yeah, we've got 146 out of 201, 147 now. So about 10 seconds to get your answers in, and I'll close that, everybody. 5, 4, etc. Just closing that poll now, and I'll let you know the answers. So, okay, it's relatively weighted towards the top of the questions. So we've got 33% of people say that development teams are just team members, neither special nor maligned.
Barely a winner there.
32% yes, say they are powerful people, but they still need to defer on things outside of their expertise. Then 20%, the next largest cohort, say they rule the roost. Developers are more respected and more in charge than any other IT team in their experience. Then we have 11% who've said that developers are useful folks who need to stay in their lane and not cause more trouble than they should. And then 4%, I'm glad that this is only 4%, but I am concerned any developers who work with these 4% of people, you know, blink 3 times if you need assistance.
Our heart goes out to them.
Saying an unfortunate necessity, kept in chains and only allowed to work on isolated systems. So if you are literally kept in chains, please let us know. But otherwise, it does seem like the development teams are fairly well respected, to between moderately to well respected in most of these most of these workplaces that we're talking about.
More than 50% have a positive view, and only 15% have a negative view. And that does tell a story. And there's obviously very situational reasons for many people in many organizations that are going to influence that. But I would say from my personal experience, and the big question that a lot of people are wondering, well, what does DevOps think? What if DevOps was a person and was asked to complete this poll? What would they say? And in my view, it's the second option. That's where, and this is, I mean, I can sort of cheat on that question because I also wrote the wording of the answers, but it's around about the second position. That is, they are meant to be a significant contributor, recognized as a significant contributor to value, but they're not the be all and end all of the process. There is expertise that they need to listen to, they need to accept, and they need to leverage. But the point of DevOps is that we do that synergistically. We do that with a positive intent with what we're trying to achieve together. And part of the first step in that is recognizing the breadth of the significance of what developers are expected to do in the DevOps environment. So we're talking about feedback into the development environment. Developers need to know exactly how their code works. How does it integrate and operate in production conditions? So there were the olden days when developers would launch their code, hand it over to someone else. Someone else would test it, come back and tell them what the bugs were. And then it would go to operations for deployment. Operations would deploy it, things would go wrong, and then there'd be a bit of panic, and maybe the devs would have to get called in at that point, or actually quite often there'd be an immediate rollback and it would go back to the development team saying it's not ready, fix it some more. So these are the old-fashioned paradigms that DevOps is trying to address, because DevOps also needs to know exactly how did this problem arise? What caused it? What happened? How did it happen? What triggered it? If the devs are going to fix anything, they need all of the information available that is usually going to come from the operations environment or the operations metrics or the stuff that operations is looking after and controlling. That's where a lot of the information is going to come from that the devs need to know. And ultimately, which we'll talk about towards the end of our discussion tonight, devs need insight into usage behavior. How is value being created from the systems and the software that they're creating? I mean, we might have perfectly working software. It might be trouble-free, bug-free even. But is it actually doing good things for our users? And would they like it a little better? And if we try to make a change that we think is going to work a little better, how do we know that's going to help? Devs need to know all these things, and they need to know them every single day, because the things that they do, the decisions that they make every single day, leverage the information from all these ideas. So the first step in making this actually work is the telemetry. And this is one of the big flagship ideas of DevOps. You have to have adequate telemetry in place. What we mean by telemetry, it's the collection of data as much as possible, vast amounts of data. Everything that we can reasonably, feasibly measure should be recorded. Even if we don't know how we're going to use that data today, we will think of something in the future. So telemetry is the vast collection of monitoring information at multiple layers. It's automated. It happens automatically. It's not something we say, oh, we should turn this monitoring on now. You might turn on visibility to some things, and we'll go through some layers of information in a little while that will separate some of those. But you want it all to happen all the time, automatically. This is not something that needs to have a manual intervention. You want enough detail so that when it's needed for diagnostic purposes, even the smallest points of data that might reveal something useful or informative can be found and used. It has to have enough detail. You also want it to be able to give you information relatively quickly. Now, this is especially true when you're doing frequent deployments in continuous delivery. You are deploying something that you've tested in your test environment. You've tested the integration. You think it's working, but there's always the chance that it'll be slightly different in the production environment. And when you see something go awry in the production environment and the operations and the developers are all sitting around watching things, what are they watching and what is it telling them? What kind of on-the-spot reporting from telemetry is going to help them understand, firstly, that there is a problem, and secondly, what to do about it, whether we go forward or backwards in resolving it, and how do we do that? And therefore, it's got to be available. And that means that whatever historical information we've collected from our telemetry needs to be available forever, because we need a situation where the developers can say, what happened last time we did this? We tried to do this before. What was the result? Why did that happen? What do the logs say? And what can we learn and glean from the logs? Because doing something about that is an inseparable part of what development needs to do. It needs to look at that, figure it out, make a decision, and use their knowledge of coding to say, we're going to change this bit. And when we do that, it'll work better, or it'll work more reliably, or in some way it'll be improved. Now, historically, there's been a mindset that telemetry is for operations. Telemetry is all the things that operations use to know when something's down or problem, the alerts, the drama that comes up in operations. But historically also, that separation has meant that quite often all that ops can do at that point is call the devs and say, this has happened and we don't know the code as intimately as you do, so we need to pass this problem into your basket. And also we need to make decisions about what do we switch off and what do we do, or do we just reboot? Maybe we should just reboot. In the historical mantra, that's often the go-to solution that operations had available to them. Hit it with a hammer and hope that when it all comes back up and refreshed, it'll be fine. And often it is. And what happened to the problem? Maybe we'll never know. Ops aren't going to go through the logs and be able to say, well, this little piece of this little code caused this interaction with this, and that's what's going to happen. That's what the devs need to do. So telemetry is as much for the role of developers as it is for the role of operations. It's another factor that tightens the loop between them. So telemetry is feedback. We'll draw a line under this, and then we'll see if we've got any interesting questions. So if you've been sitting on one, put it up in the questions box. This is a paradigm where the feedback we're talking about now comes from automation at this point. We'll talk shortly about other layers of feedback, but right now we're talking about feedback from the system. Feedback isn't just the personal feedback where, you sort of have to say, hey, can I give you some feedback on that? That's not what this is. At this step, we're just talking about any data that gets pushed into our field of view, or perhaps pulled, but it's things that the developers have specifically put into the telemetry, into the monitoring that says, I want to know what happens here. I want to know if this happens, or I want to know how much this happens, or I want this data reported because I need to know about this because this is going to tell me something. So it's systemic feedback. It's telemetry that's been predefined as something that would be useful. And because we don't have to intervene when it's running to make it happen, it's always there. It's always available to us, just in time, which is an important hallmark of everything we do in the DevOps environment. So it's feedback that we can always get access to right when we need it. And this is something that the devs have a great deal of control over the questions that get asked. Now, they don't have unique control because ops have a lot of things that they want to monitor as well, or need to monitor. But having this accessibility means that the developers can say, well, in order to do our job, we need these questions answered every day, all the time. And maybe some new ones that have to get answered with our next deployment. How are we going, Jack, with questions? Do we have a few?
We do. We've got a number going on. So let's start with the things that are most relevant to what we're talking about right now.
Okay.
Andrew has asked, if everything possible is recorded in telemetry, what about the privacy of customer data in production systems?
So telemetry is typically going to give you statistical data. It doesn't usually capture sensitive and private data. It captures events, it captures things that occurred within the system, but it doesn't have to capture who. It might capture things like a record ID, customer ID, a database field ID. It might capture that sort of information in those visible logs, but it doesn't need to convey the sorts of information in those fields unless there's something diagnostic within that. So we've all seen those moments when a database field setting is the reason for a crash or failure, where the database field hasn't been specified as long enough, or it's not dealing with a certain special character correctly, or things like that. And in those moments, we might, as part of the diagnostic, need visibility to something within that. But what should come out of the telemetry is the kind of scripted alert that says there was a computational error with something in this field that caused this kind of computational error. And we might not need to look into that field to know what that was. We might be able to determine from that, hey, this is what it is. So it's not meant to create security loopholes. And that is one of the parameters that needs to be considered when either devs or ops are writing and creating telemetry requirements. So it can sometimes be a bit of a safety rail.
Great, thank you. And I suppose that also leads into a quick question from Jesper asking if telemetry would also include data from the tickets in an IT service management system used in a call center, which is fairly specific, but maybe that makes it easier to answer.
So there's certainly, you could certainly have situations where tickets are created relationally to monitoring data. They can be an appendices to the reporting. You would probably start with log because you're looking for certain things that stand out, and tickets stand out. So a ticket alignment is a way in to a look at the problem. And often you might look at tickets as a starting point to say, okay, these are alerts and triggers that have come usually from a user perspective, or maybe internal tickets as well. They are a starting point, and they will give you interesting information. But usually after that, you start to have to look at the telemetry to start finding information that will reveal answers to it. So tickets are usually incident related. So they're usually symptom related. So they're a piece of the puzzle, but they're not usually going to be an integral part of the automated reporting. But if you can synchronize, then it's useful. But who's going to know whether or not for this particular incident that's been ticketed, that these are the logs that are going to be relevant? Sometimes there's an obvious match, but sometimes there's not. So we don't want to assume that any ticket is going to already have connections and affiliations with whatever logging that is part of the investigation process.
Thank you. So we've got a couple of questions. Mohammed has asked, how does operations get greater visibility and knowledge on the code that is being deployed?
So when I talk about it tonight from the development perspective, and I talk about the role and responsibility of developers, that is not to say that operations are not working side by side. They are working side by side. So when you have deployments, you have operations engineers, development engineers looking at the same problem together. You have developers before any deployment happens providing a report on patch notes, a detailed list of exactly what's going in this particular code launch, so that operations gets a clear visibility before it happens that these are all the things that are going to change. And that's their opportunity to say, okay, well, you're going to do this. Have you taken this into account? And the answer might be yes or no. So operations gets that window to say, we have input here. We have feedback to give you before deployment. And that's part of the reporting that happens just before the deployment. Now, some systems, some highly paced systems actually skip that step. They actually don't have development reporting to operations. Development manages deployment on their own. They do inform and they do provide the information, but it's happening in that situation. It's happening every single day. There's always going to be a deployment. And yes, there's always going to be a list of things that you can go look at, but it's the developers that are the ones in the call looking at all the things and deciding, okay, we're going to pull this change out and pull this change out. This coder is not confident. This coder is not here on the call. So they're out for today's push. And what's left is what goes live. And often developers will make that call and push that out. So in those situations, ops are not taking responsibility for the successful deployment of the code. What they're taking responsibility for is the successful operation of the environment that supports the code and the successful feedback into development as soon as something out of the ordinary happens that development needs to know about it. So not every organization tells ops that you need to know everything that's going on. Different demarcations can arise.
Great, okay. And I suppose that talking about the demarcations between what is dev, what is ops, etc., Thirsty is asked, in the commonly recognized DevOps infinity loop, operate and monitor in the ops side. Is this telemetry feedback part of monitor? And if so, is it then ops only?
It is part of monitor. It is essentially the data that gets monitored in that loop. But no, it's not ops only, in the sense that a lot of what exists in the telemetry that gets created was specifically put there because devs needed to see the results of something specific at the application layer, which ops have no interest in. Well, I wouldn't say they have no interest in, but ops aren't necessarily involved with the code to a depth, as they're not developers. They're not involved at a depth that lets them work with that data. So there's a level of reporting that's going to happen purely for the benefit of the questions the devs are asking. That's this point here. Devs are asking specific questions, and telemetry that's there might just be for that purpose. So it's not ops only in that regard.
Okay. I'd say let's do one more perhaps on this kind of topic. Chris has asked if instrumentation is the same as telemetry.
Instrumentation, it's an interesting separation, because I would describe instrumentation as the things you use to do the monitoring. And so instrumentation more often associated with hardware monitoring or systems monitoring. But I don't know that, I mean, people will have their own specific words and labels for certain things. It's not the same, because telemetry is typically talked about all of the data. So telemetry isn't the stuff that does the monitoring. Telemetry is the results of the monitoring.
So you use the,
yeah,
would you say you use the instrumentation in order to do the telemetry? Is that too oversimplified?
Yes. Well, no, that's not. No, that is a simplification, but that is one way of describing it. I would agree with that.
Right.
Instrumentation is one of the things that you would use to create your telemetry. Yeah.
Great. And just a really quick one, because I find it quite amusing. Ray's asked, what do you say to developers who publish error messages such as, "Oops, something went wrong"?
So what I find interesting about that, and I'm going to assume a context there with that question, and that on the one hand, the positive is that there's a curiosity, there's an investigation, there's an awareness of a failure, there's awareness that something happened. And from the other point of view, you're really hoping that that's not the end of it. And you know, the context I'm assuming here is that Ray may be suggesting that sometimes that's the end of the report. Yeah, look, something happened. And if the devs just don't have a way to figure that out, who are you going to call? What are you going to do? Where are you going to go? Where can you look? How do you fix that? You know, do you just roll it back and put it back into staging and say, well, now let's start at line 1 and see where we can find this thing? And part of the point of telemetry is saying that answers like that, reporting like that says, yeah, it's something, yeah, you're meant to be able to solve that uncertainty and that vagueness with some degree of telemetry. And you don't always, but some of the most problematic situations I've encountered is disenfranchised developers who either don't have access to asking the questions, they just don't have enough influence over telemetry to get the stuff monitored that they want monitored. And so they're stuck. They can't ask the right questions, either of the ops team or of the environment. They can't get the data, so they can't fix the problem. And that is something that DevOps is always trying to fix and resolve, so that you never get stuck with this, I don't know, but here's a funny quote instead answer.
Great.
That's a good question, Ray. Thanks for that one.
Yeah, thank you. Shall we move on for a little bit and come back to a couple more of these questions later on?
Let's talk about analysis then. And I want to give you a few examples, and this is where some of you might be familiar with some of this. When we talk about analysis, we're talking about many ways to analyze and visualize the vast amounts of data, the telemetry that we have, and how we analyze it is going to be fit for purpose, whatever we need it to do. So we're looking for specific kinds of things initially. And this is where you have a difference between the way in which developers and operations are going to be investigating and analyzing. So this perspective is putting aside the fact that some developers are going to have very targeted questions, and they're going to say, that thing I launched yesterday, it's meant to be doing this, this, and this, and I need to see my log reports to see if that's actually exactly what it's doing or not. Ops are saying, yeah, good, but look what happened to this bell curve over here. It's gone crazy. So you're going to have reasons to look at anything out of the ordinary. And a lot of this might be triggered by ops, but it's often going to be the devs that are going to look into it if it's in the application layer. Now, I just want to be clear. If you've got things that are environmental, systems, physicals, hardware, then obviously that's less likely for the devs to be involved in that. If you've got things that are at the application layer, then you're almost certainly going to have development involved in solving it. So we use different tools, statistical analysis, visualizations to help us try to find the interesting thing that we're then going to drill down on further. Now, when you have a question to ask, your interpretation of the results is going to start with that. But if you don't have a question to ask, you have an interpretation that begins with something that's not like the other things. So developers are usually the ones, when the question comes up and says, well, here's our graph and here's a number over here. Why is that there? How did that happen? Why is this existing? It's usually in the application layer, the developers need to answer that question. And so there needs to be an integral involvement for the developers with the analysis of what these things are. So this is where you have another feedback scenario between peers. You have operations in possession and required to look at and analyze vast amounts of reports and data and graphs and charts, and they spot something because they're experienced, they're well-trained, they know what they're looking for, and they spot something, but it's just a number on a graph. What does it mean? DevOps requires that there be enough synergy to say, well, we need to talk to devs about trying to figure out even where to look for this problem. So you're searching for outliers, statistical anomalies, something that's outside of the averages, or you're looking for something that's exceeded a threshold. So you have thresholds where in your telemetry, you're looking for reporting that says, this has exceeded a threshold. Now, we're kind of familiar with those sorts of reporting. We kind of have been doing that in IT for a long time to various degrees. So these parts aren't necessarily a surprise. We have our thresholds. We look at things that go above or below. We have trends where a repeated instance of outliers or repeated breaching of thresholds might tell a story. A value that's above a threshold by a little bit, and then a little bit more, and then a little bit more than that, that's a trend that we might want to pay attention to. Because we might have another threshold that's a really bad one, and it hasn't reached that, but we can't ignore it because the trend says that by next week, it will reach that. So these are where we have indicators. And often we talk about two different kinds of indicators. We have lead indicators and lag indicators. And really, they're just about how we are able to interpret the data and are we able to look forward or backwards. So lead indicators are things that tell a story that suggests a certain thing is going to happen in the future. So I'll give you an example of the traffic light. When a traffic light goes amber or orange, that's a lead indicator that it's going to go red, because that is something that we know happens when it goes amber, right? So that's when this happens, this is what happens after that. And so you have lead indicators to say, well, because we see this data in our report, we're pretty sure that this is what's coming. Lagging indicators are historical evidence. Lagging indicators are going to be things like, well, every time someone goes through a red light, there's a X% chance, or every so often this happens, there is a collision. And we can look at collision reports and say, well, you know, every time when these people go through red lights, 10% of the time they hit somebody else. So there's a lag indicator. It doesn't tell you anything about the future, but it tells you a lot about the past. So different indicators are going to reveal different things out of the reporting that we look at and how we analyze them. And again, there's this never-ending link between the question, do we want to know what's happened in the past? If we've got a query about accidents and what happens and the consequences, we might have a query about insurance. We're going to be far more interested with an insurance query about what happens with the historical value of red lights and accidents. But if we've got query about, well, should we change the timing of how long lights are amber? Or we're going to look at the leading indicators. So there's different levels that we might log things at. And I've given a blanket idea thus far, but there are some different layers. We might log things at the debug layer. And many of you have used this and heard of this before. This is the log everything. Now, this usually has an overhead. This is not something you have on all the time. This is one of the things that this kind of monitoring, you might turn on selectively because the investigation you've done thus far has narrowed down what or where the problem might be. And so you say, well, these activities, when users do this thing, can we turn on debug logging in that particular section of the code? Who created the debug logging? Who set all that up? That was the developers. And if they've done a terrific job of creating the right kind of debug logging, they will then be able to collect vast amounts of data, which is probably going to be too much to live on all the time and an overhead on the system's performance. But that's going to capture everything. And that's where we might start looking for things that might or might not be where the problem lies. Information reporting is often talked about as things that are actions, user-driven things, an event that takes place proactively, something that occurs where a system says, we're going to do this now, or a person says, I'm going to do this now. Warning, logging levels, these are the sorts of things that are typically on all the time. These are things that are conditions that could become an error. Warnings would be things like when bandwidth is getting close or getting past 80% of the capacity of a pipe. It could be where RAM is getting close to a particular percentage of its capacity, or CPUs when you're talking hardware. It could be that database fields a database field is filling up. It has a capacity to store a certain amount of data. The value in that is not meant to exceed a certain amount. If it does, that's a warning. Something isn't right there. And we set that as part of our reporting. An error condition is where a condition says that something has not worked as expected. So warning is the potential error, and the error logging is, well, that's an error. That's something that should not have happened fundamentally. Now, we might have a lot of those things that happen in our code, and they don't necessarily break or fall down or become an utter failure. But some piece of it had a problem. We might have a try again. It might be a process that can simply retry. Or it might have an unrecoverable error. Fatal logging levels are things where something had to stop. Some action had to terminate or be terminated. So organizations don't have to specifically use a particular nomenclature when it comes to logging. But you do need to make some decisions about, in your telemetry and in your analysis, how much do you need? How much can you have? What kind of overhead on the collection of data can you afford within the application layer in particular? And how are you going to use that? Let's look at some examples. Example of a bell curve. So this is a Gaussian distribution or a bell curve. Now you have values across two axes. The median is this point in the middle. All right, so this is the mean, this is the middle. And things that deviate left or right, you might say they are either side of that average or median. But you might say, well, something here, yes, it's past the average, past the middle, but it's still on the curve. It's still an acceptable value because relevant to these two values, it's in the right position. It's giving the right report. You might have something that's not, something that's over here that says, okay, we've got a value that is outside of the curve. So we're not just looking at a one-dimensional threshold that says, okay, here's our line, right? Here's our line here, or no, maybe it's here. Here's our maximum. So if it's above the maximum, we're going to get alarmed. No, we're actually going to be alarmed by this, because given the point on the value here, it's above what it should be. Because if it's aligned with this value, it should be here. The y-axis should be here. You might actually look at something that's below, values that are below. So this is where we'll use statistical models like bell curves to say, well, where's the anomaly? Where's the thing we've got to look for? Now, usually your reporting isn't going to create graphs that are perfectly shaped like this one. It might give you graphs or reports that just don't fit a Gaussian distribution. if I give you something like this, where if you look at this threshold here, this line that's here, right? It's exceeding this every day. Every day, where well, usually day is a popular cycle for things, and it's going above this line. Now, that might be our average, but every single day it's going above that. Now, we want to make sure that we're not responding to unnecessary alerts, because we might want to say, well, we're going to measure the degree to which it goes above, and we're only going to worry about it when it exceeds by a certain value. And we're going to collect information over time that says, well, we're going to look at the report that says, over time, this might be getting higher and higher and higher. It might still be below our warning levels, but it's still going up. So you have things to look at that says, well, I'm going to look at this. If you were looking at this graph, you might be very interested in this value here. Obviously, that makes sense. But you might also be interested in these, because these are narrow. These are not a collection of data points. These could be individual data points that suggest that something anomalous happened in that moment. You might be looking at this one. See how this is the lowest of the lows down here? This might mean something. It's also got a fair bit of width to this report. Now, whether or not this means anything to what we're trying to do, that is for the analysis to determine. That is for operations who might be saying, here's the report, and sitting with devs to say, okay, does this mean something? We're not too worried about this down here because it's not much of a variance. These things keep happening. They're happening regularly, but they're not breaking anything. This thing broke something. So let's start there. Here's another one that talks about smoothing. So if you look at the red line, you'll see that it's going up and down. It's having a tough time. There's peaks and troughs that happen over a period of time. But when you look at the blue line, that's the result of smoothing. We might not be that interested in the fact that on any given day, it's marginally above or below its medium or its average. What we might be interested in is the fact that it's done this and then it's done this, right? We might say that's really interesting. So these things we might say, yeah, a bit of a spike, but when we smooth it out, it's not that far off. But this, the suddenness of this change, even our smooth, even if the red line didn't exist, right? Even if our red line wasn't there, we still know that events down here, probably something worth looking at. So many different ways we can analyze the data and try to find the thing that we need to look at. This is all highly subjective. It really does depend on what it is you're looking for. The point that DevOps is trying to make here is that we need to have the right telemetry that's giving us all the right information. And we need to have ops able to and willing to find all these details and have dev then interpret them and understand that, oh, this happens when my code did this. And so I need to look at that code. So development feedback to the development team, the peer feedback, the system feedback, it means that the devs have universal responsibility as part of every step of that process. They need to prepare the telemetry for the application layer. They need to be able to say, well, these are all the things I'm going to monitor. They need to be able to ensure that when they integrate, they're integrating with other telemetry. They're monitoring not just the thing that they created, they're monitoring how it interacts with other things. It means that during deployment, devs are involved. Some DevOps organizations have the developers take part on a rotating basis with the alert monitoring after deployments. They are involved in rapid response because they are often, their expertise is often essential to deciding whether or not do we suddenly urgently roll back. They manage anomalies that occur, especially out of the application layer or caused by the application layer. They might work on immediate fixes. You might even have that fix forward situation where the devs say, oh, I know exactly what that is. That's this value. And we weren't sure whether it was going to be result A or result B. So we're going to say, we're going to change it to the other result and we're going to fix that right now. Let us push a change out right now. And then it's, well, no, we're going to pull that code out. We're going to deactivate that feature, and we're going to go back into the test environment tomorrow, and we're going to make some changes that'll fix that now that we know more about how it's really working or what really went wrong. So this is DevOps empowering telemetry at every step and from every step. This is the feedback that everything that happens in operations has the potential to inform what the developers do tomorrow or in the next hour. And DevOps wants us to understand that everything we can do to empower each other in either direction is valuable in the continuous delivery. Now, before we get into the final step in there, I just want to check with Jack, see if we have any more interesting questions we can tackle, because the last little bit we're going to talk about now is the final step, which is user and customer feedback. How are we going with our questions?
We haven't actually received very many more questions, but Dustin has gone back to the telemetry discussion slightly and asked if telemetry encompasses traces, metrics, and logs, or is it more?
Well, yes, it does encompass all those things. And the more is an open-ended question. And I would say that the short answer is yes. It can be a lot more. You can, when you talk about metrics, you're talking about any comparable value. But the point is about the comparison. You might look at metrics and say, well, we're looking for these things. And I did talk a fair bit about looking for answers, posing questions that the telemetry should answer. But in looking at that analysis discussion, telemetry is also meant to tell you the thing you didn't think to ask. It's meant to be able to reveal to you the question you should have asked. But because you don't have a crystal ball, you didn't know that this thing was going to happen. But the telemetry was there to save you, because the telemetry had that thing that said, here's something unusual. You know, we've captured this little bit of information, and it's up to ops and dev to figure out exactly what that means and what, if anything, to do about it. So yeah, I would say you go beyond what you know you're trying to do, and you're incorporating a broader net that hopefully gives you something that you didn't expect, because that's exactly why the monitoring is there, to catch the things that you also didn't expect.
Great,
Yeah,
thank you.
No limits.
No limits. Fantastic. We've got a couple sort of around the limitations. I might bundle a couple of these together because they do seem to be around the limitations of the definition, I suppose, of DevOps.
Yep.
So Gary has asked, where does the business analysis come into DevOps, or the business analyst come into DevOps? Mohammed has asked, what is the role of service management in the DevOps model? And Harish has asked, what is the difference between project management and DevOps?
So let me do them in reverse order, because I think that's probably a little bit easier conceptually. And project management is usually referred to as something, a project is something that has a defined start and finish. So a project and project management is something that has fixed values, a fixed something, even if it's an agile project, some value is going to be fixed. Maybe it's the budget, or maybe it's the duration, or maybe it's the outcome. You know, we want this, we don't care what it costs or how long it is, or, you know, it's got to be done by this date, whatever we can get done. But there's always some variable that's kind of fixed. And usually there's an end date, at which point you call the project closed and it might become something else. But DevOps is about a value stream. Now, you could say from an agile point of view that an agile project, or rather an agile value stream, is just a project that never ends. You could view it that way and say, well, when we talk about an agile thing that actually doesn't have an end date and doesn't have endpoint criteria, it's just never-ending delivery, and we're just going to keep improving it forever until we turn it off. That's value streaming, and that's what DevOps is there to service. So you might have things that may get built from scratch, from absolutely nothing, using project management and perhaps agile project management. And then they might go into a continuous delivery model with a value stream using DevOps that says, well, now you've built it. It isn't perfect. You're going to perfect it. every single day for the rest of its life. And that's what DevOps will do. So you go back to service management. Service management is, I think, from my perspective, it's very much involved with, if you talk about service as customer service management, as opposed to IT service management, there's a little difference. Although things like ITIL create the overlap that service requests from customers and incident management are often sort of things we have similar processes for. So service management is usually the ops side and is usually the trigger. They are often managing incidents or managing user-related activities. Service management often also responds to alerts and events that are causing a reduction in the enjoyment of the service, so a reduction in value. And so service management is often the thing that says, quick, reboot it. No, we don't have time to call the devs. They're going to think. We don't have time to think, reboot it, because millions of dollars are being lost as we speak. And service management are the people in the role that have to make the decisions that say, what can we do to preserve the continuous delivery of value and maximize that? And sometimes that means just incident management, but there's also, according to things like ITIL, problem management. And problem management, that's where the devs come in. Sometimes they come in with incident management, but it's more of a problem management alignment, except with continuous delivery. Unlike ITIL, in continuous delivery DevOps, you solve the problem today. You hear about it today, you solve it today, because tomorrow you want to push out the fix because you're pushing something tomorrow or whenever the next time you push is, and you want your fix to be in that, because why shouldn't it be? I mean, why make people wait, right? If it's a small thing, unless you have to because it's enormous, yes, but the goal is push it out there now. So problem management is handled in a far different way than you get in other traditional IT service management. So Gary's question about business analyst, and I want to suggest, Gary, that we'll tackle that in the next slide or two, because this is really going to answer the question, because the business analyst has the question of what's the problem? What are we trying to solve here? And when I say what's the problem, what's the customer problem? Or what's the business problem? The business analyst has a role to say, okay, I'm going to convert and interpret a business need into a technical requirement, specification, outcome, something that developers can understand and work with and deliver. I'm going to help translate what might be a huge pile of user stories into something that actually can be technically delivered. And so there is a very special function that we're about to talk about, which is hypothesis-driven development, that gives DevOps a significant edge and has a strong role to play with business analysts. So we're going to cover that then.
Great, thank you. And okay, we're just having a look at these next questions. We've got a couple. Gary's asked us as well, shouldn't development have an arm's length relationship with testing, which harkens back to a little earlier in the piece, but what are your feelings on the relationship between development and testing?
In general, DevOps says no. DevOps says they are brothers in arms. Development and testing work so closely together that you might even say in another 10 years, we've stopped separating them. Now, there's going to be some things that you're going to say, well, hang on, some things need to be blind tested. Some things need a change in perspective. Sometimes the developers are locked in a viewpoint and they're not able to create automated testing that actually tests their stuff. And that happens, and that is supplementary. So you do have situations where an arm's length separated form of testing, perhaps with things like security, are going to be necessary. But as a general statement, DevOps is usually saying, no, sit on the same chair and figure it out together. Because the tighter you can make that work, the faster and more efficiently you can deliver quality. It's not, in DevOps, it's not about, okay, you do a thing and I'm going to double check how you've done that thing. That's not the goal with DevOps. DevOps is just deliver quality. And if we can do it in such a way that the devs deliver the highest level of quality first time through before they even let it go, that's success. And so the tighter we can weave testing into that process, the more success we can get as a step 1 success, and the less step 2, 3, and 4 knocking it about that we're going to have to do.
Great. Thank you so much. And okay, we've got another question from Greg, who has asked if DevOps favors making small changes to a big system that is growing in complexity, won't the law of requisite variety become a limitation to performance?
Wow, Greg's thrown a curveball at me.
That is, I was reading that, and as I was reading it, I was like, this is complicated. Yes.
Yeah, and I don't have time to look that up and brush up on my understanding of that.
Maybe we can answer that next week, or feel free to launch into it.
Look, I'm going to suggest to Greg that I answer that in a post on the forum in a little more detail, because I really don't think I'm going to do it justice at the moment. But I think if we're talking about the law of requisite variety become a limitation, well, let's take a step back and say what's going to become a limitation to performance. The complexity itself does become a limitation to performance, because everything you add adds overhead in some way. Everything you add adds overhead to integration. Every bit of complexity adds overhead to something else. And then you get a point where you say, well, at what point do we need to split? At what point do we need to segregate and section off? At what point do we need to isolate and break apart the complexity into smaller pieces that can then be looked at, worked on, and interacted with and integrated separately? So that's at odds with some of the way cloud computing is actually being developed at the moment, because bigger and bigger complexity is kind of the name of the game. And this is one of the reasons why DevOps has been developed. So I think that the enemy of complexity is universal, and it's not something that DevOps necessarily has a big answer for yet, other than to say, well, if we are continually tight with what we do, we are maximizing our success chances and our value delivery. But complexity is a structural issue rather than a process issue. And structure can be answered in different ways. So, but I am going to come back to that question. So if we can, Jack, if you could help me capture that and send me something on that, I'll tackle it in the forums.
Absolutely, can do.
All right. Let's finish our last point and then see if anyone has any last minute questions to pop up over the next couple of slides as we go through. I've only got a couple more slides to cover. I want to talk about hypothesis-driven development, because it's the last piece of the puzzle when it comes to feedback, in particular for the developers. What we're talking about now is devs getting feedback not from operations, not from the systems directly, but getting feedback on value, how the users use it, how is this stuff leveraged? What this is tackling from DevOps point of view, to make a contrast, in historical olden days, you'd build something and you'd build it and you'd build it and you'd build it. And then only the first time you would know whether or not you've built anything that actually is useful is once you've built all of it. That might even be the first time you know whether or not it works. And you'll have a testing period. So I'm talking about waterfall scenarios, right? You've built a thing and you've tested it a lot. And finally, the users get to play with it. And they say, oh, this isn't what I wanted. Now, yes, we invented Agile and Scrum and XP and stuff like that to help us solve that. We invented the Agile ways of dealing with empirical project design, where even from the very beginning, the customer didn't know what they want. But that's not what this is about. This is about something that's live. It's there. It's out there already. It's doing its thing. Now, if you've ever had as a user, you've ever had something that in something you use, most likely in a mobile app, and they moved something. They moved something. Safari did it brilliantly recently. And I say brilliantly because I mean, as a brilliant example for me right now. Safari moved the location of the URL, the field where you type in the URL. They moved it from the top to the bottom. Did anyone notice that? Well, you know, iPhone users out there might have noticed that, right? That's an example of a massive change for users. Now, if you're saying to me, what? They did what? I didn't see that. Then maybe you are seeing in action hypothesis-driven development and incremental development, customer feedback process. You can have feature toggles. Now, one of the ways feature toggles work is that you put the code in, you integrate it, you send it out there, but you don't turn it on. You don't let people use it yet. Maybe the only people that are using this code is your testers. It may not be the devs, your favorite clients, or the handful of people that are out there using it who know about it, and they're using it. But then you turn it on to a few people, a few more people, and a few more people, and a few more people, so that you have effectively got a split testing environment. A split testing is where you have an A and a B, and you say, okay, well, A is our default. That's what most people use. Our B environment, we're going to say, well, just 1% of our users are going to have access to that. And we're going to see how they do, see what happens. We're going to look at our telemetry. We're going to analyze our logs. And because we know what we've changed, we know what to look for. So we've written telemetry and we've written logging that looks for specifically the outcomes that we want to analyze. And we're saying, well, okay, those 1%, yeah, no, that's going in the direction we like. Let's make it 10% now. All right, let's make it 30%, 50%. Continually get the numbers. Oh, hang on, no, this isn't working. Problem. Scale it back or turn it off, or don't let anyone else get it. And we're going to make a change to that. And then we might have an A, B, and C environment even, if necessary. But we have multiple versions, and you might have them randomly. If it's a mass user environment, you might have the different groups that are randomly assigned. People will get to a website, and randomly, a certain portion of the people are going to see the new testing version, because all of the analysis is going to be able to tell the developers whether or not that worked better. So things like they look at logs that say users spend X number of seconds on this page before they click this button, and Y number of seconds before they click that button, and Z number of seconds before they click that button. And the Z number is double. Well, what's wrong with the Z? Why are people taking so much longer? If the Z is where they're going to go next, why does it take them so much longer? Let's make some changes. Let's help them get that. Let's move some information around. And then we're going to see what happens for the next week. And then they find that suddenly the people that went in the Z direction, they're doing it much quicker now. Oh, good. We've fixed a problem. Now we can start to say in the split testing, well, let's let everyone use it. That's the new A model now. And if we change something in the future, there'll be a new B. So we might have these incremental release. Now, this is very much a application layer scenario that I'm talking about. You have greater portions of your users or your systems that get incremental access whilst you're looking at the data and you're deciding that, yeah, it's okay, we're going to increase that. Now, where that fits into hypothesis-driven development is that it means that experimentation is the key. Experimentation is the answer. So you may never talk to your users, the developers, for example, may never talk to a user. You're not going to ask them any questions. You don't even want to send them a survey, because like, who fills in a survey anyway, right? So you're going to have to figure it out some other way. The DevOps environment of continuous delivery gives you an absolute golden opportunity to figure out what's going on and adapt to it quickly. Because if something doesn't go right, only a small percentage of your users have been affected by it, and you can fix it tomorrow or whenever your next code push is. But what that means is you can experiment. You can say, hey, we're going to do this now. Oh, look at that. Half our users have stopped using that system. Quick, change it back. Or you do what some other organizations are inclined to do and say, tough, they'll get over it. Let them deal with it. It'll be good for them. We know what's best for them. It'll be good for them in the future. And besides, they'll forget it was even changed at some point. Now, there's some terrifying statistics and analysis and research that has been done in the recent past that suggests that in some situations, in some industries, as many as 2/3 of the improvements that devs thought they were doing actually weren't, according to the users. 2/3. One particular company was once quoted as saying, hey, look, you know, that last month that we spent building those features and pushing them out, we would have gotten better value and bang for our buck if we'd sent the entire development team on a holiday for a month and they'd just taken the time off, because everything they did in the last month has not increased the value of our product at all. Maybe them coming back from, you know, a bit of a holiday would actually be better for us than what they did, because we never checked, we never looked, we didn't know, we didn't have the telemetry in place to figure out. We didn't get the answers fast enough. We weren't looking at it. Ops wasn't talking to the developers. The developers weren't asking the questions. They weren't putting their telemetry requirements in. Nobody was experimenting in a safe and controlled way. You have a mechanism with DevOps that lets you push quality code on a highly regular basis. That can include investigations and experimentations that help you figure out whether or not this new feature or that new feature is going to be good for you, or good for your users, or good for your value stream, and ultimately good for the bottom line of the organization. It's becoming very common now. And you as a user, you might not notice it. You might not be aware of the fact that when you log onto a thing, you're seeing a slightly different version of something. But you'll be collected as part of statistics and how you respond to that. And if you have enough users, then you'll be able to gather enough statistical information that will hopefully tell you whether that's good or bad. Now, obviously, very small organizations with very small user counts, with bespoke products, etc., might be a little different. But the typical DevOps environment are usually larger scale, where you have enough data to draw from. So that is all of the things that DevOps is asking us to think about when it comes to feedback. And yes, all of that feedback ultimately ends up in the developer's hands, because everything that needs to happen as a result of that feedback will fall on the developers to do. And so the tighter we make those feedback loops, the more effective the entire organization can be. And DevOps asks us to culturally recognize that, culturally accept the fact that this is the role of development, and this is how tightly woven it is to all the information we have. And so this is how we need to have these expectations. Devs need to be expected to do a whole bunch of stuff that they weren't really asked or invited or needing to do in years past. But they need a ton more information and help and feedback in order to do that than they ever needed before in the DevOps paradigm. Let's see if we've got any questions.
Fantastic. We do. We've got a few. So speaking of that feedback loop, that tight feedback loop, Harish has asked, what about feed forward? Is it referred by devs or ops or customer?
So feed forward is usually through the cycle. Right? So when I looked at the cycle earlier, when I talked about, and I was talking that cycle was from a dev's point of view, but you look at the cyclic, the infinite loop of what happens in a DevOps environment. The feed forward is any point that's feeding information into what's about to happen. So an example is one that we talked about, where in a deployment, the dev team will say, okay, here's all the things that are going to go live. Here's all of the reports that might start making a noise. So ops gets that feed forward information and says, oh, okay, we need to keep an eye on these reports for the next few hours because they might tell us something interesting. So you get feed forward examples from that. You obviously get feed forward examples where you have a closer relationship with customers and you're saying, well, customers, this change is going to happen. This is going to be, in gaming, it's called patch notes. In other environments as well, but gamers love to read their patch notes. It's the sort of thing where you want to see what's happening to your game and how you're going to work with it. Customers of productivity software, less so, but you might still have a feed forward information in that environment using the example in the question. But most of the time, you're saying, okay, feed forward is anything that's about information that's relevant in the future. It's usually from devs into ops.
Great, thank you. More of a comment than a question, but I do think it's funny. Someone said, we have one business user who believes in trying to break every new version of everything, which I think is, that's helpful in my opinion, personally.
Look, in DevOps, yeah. Bless their cotton socks, they're the ones that are going to help prevent, not automatically prevent, but hopefully help a team to prevent them from being in a situation where everyone breaks everything. because that one person broke it first and we were able to fix it. Because if they can break it, others can break it.
Exactly.
That's the whole thing about security vulnerabilities, right? If you're not taking to it with a sledgehammer, then you don't know if it's actually breakable or not. We'll talk a bit about this next week, because we're going to talk about knowledge and knowledge sharing. And one of the things in DevOps, in knowledge sharing, is that you should be willing to embrace failure and willing to break things until you know they can't be broken anymore. And the only way you're going to know that is because you've kept trying to break it and it didn't break. And so knowing the limits of something, destruction testing. You know, we've only got 1,000 users. We're only going to test it to 1,000 users. What happens if we get 100,000 users? Who knows? Who cares? Well, let's do that test anyway. Let's find out that actually it fails at 1,200 users. Ooh, good. Glad we figured that out. That sort of thing. We'll talk more about that next week.
Great. Now, I might actually, just because we've only got a few minutes left, sorry, 1 second. I'm just asking Kit a question briefly. We've only got a couple of minutes left, so I might just run through a couple of things. I do want to mention very quickly before people sort of start heading out that once again, if you missed it earlier, for people located in Australia or particularly Victoria, next week, we will be running the webinar at Thursday at 7:30 p.m. Australian Eastern Standard Time. We won't be holding off on doing that for the several public holidays that we have in a row here in Victoria in particular. So that will be available. And also we should mention to everyone that we have a survey that is available on the course page on the learn.itmasters.edu.au. And we would love for everybody to fill in that survey. It is fantastic. We love to get feedback from you, and we love to know what you think about this course, any other courses that you've tried, anything that you'd like to see in the future, your experience in general with that. We absolutely love to hear it. It helps us refine and improve our practice constantly. So the survey is available. We've had just a reminder really quickly that the Q&A is closed for now. But there is the opportunity to ask and have answered as many questions as you like on the forums, learn.itmasters.edu.au as well. If you are interested in any of the additional resources that you'll be able to see on your screen currently, you can head to just plain itmasters.edu.au, or the link that Kit is about to drop in the chat to have a look at your eligibility for future study with ITM and Charles Sturt University. So we will, yes, there'll be plenty of opportunities to have a look at some of our further courses. And thanks very much, everybody, for joining us today. Please, once again, enjoy, the exam. Yes, of course, the exam. So the exam will be available once the final week has concluded. I've got, I had the, my apologies, I did have the details of it up on a different, it's on the course page. So Kit has just posted the course page in the chat as well, learn.itmasters.edu.au.
Is it like straight into the webinar, or is it the next day, or what? Because I need to know that.
It will be opening on the 23rd of September. So that's the next day.
The next day. Okay.
After the next webinar. And you've got as long as you would like to complete that, if you would like to do so, and get your certificate. And there'll be one attempt at the exam. It is generally, correct me, Brenton or Kit, if I'm incorrect, but our exams for short courses tend to be 1 hour of time to complete. They are primarily multiple choice, and you have one attempt at them. Certificates for completing the exam and passing it will be available the following week. So Kit is thank you, Kit, for popping those in the chat currently. And thank you, everybody, once again for coming along this evening. Good morning, afternoon, good evening, good night, etc. to everybody. Was there anything else that you needed to mention before we log off for today, Brenton?
I was fascinated by the little burst in chat activity when I mentioned that change in Safari on Apple. I think that resonated with a few people. And I did notice, and I thought it was worth mentioning in light of that question from Gently George saying, well, how do you have a KPI of success for that? How do you know if it's good or not? And so if they're measuring things with super telemetry, they're going to be measuring delays. They're going to be measuring the distance, the time taken between when a new URL is entered into the same browser tab. So they're going to have some way of subjectively measuring how much time it took for people to type something in. Now, the change could make a lot of sense logically because most people are holding their phone in a certain way. And what do you type with? Usually your thumbs. And where are they? Usually at the bottom. And so the idea of saying, well, if you want to type in a URL, probably shouldn't it be up there or down there rather than up top? And you think about that, you think, oh, man, how did it take them so long to figure that out? I don't know. Is it a good thing? Everyone has to make their own choice. But would there be absolutely there'd be KPIs that you could measure, assuming you had the telemetry for it. But if you don't have the telemetry to measure intervals and time gaps, you've got no idea whether it's the right thing or not, even if you think it is. And that's what tonight's discussion was really all about. So thank you, Jack, for your MC handling, managing everything. Thank you, everyone, for the wonderful and busy chat that's all been happening. Thank you, Kit, for handling all the back-end questions, etc. And thank you, everyone, for all of your great questions. And please throw more of them in the forums. And until next week, that's all from me and from us for now. Thank you and good night.
Thanks very much. Good night, everybody.